In this video, we're going to fit a quadratic function to some given data, but we're going to discover that it's not quite a perfect fit. It's a very good fit, but it's not a perfect fit. So we'll start by highlighting the data values that are provided in Excel. And we'll go Insert, and we want to insert one of the charts, and you always choose Scatter Plot for this. And you want to choose the option of scatter plots that does not connect the points with lines. There's no point doing that. So here's the graph that we have obtained. And if you look at the shape of the data points, the shape of the graph certainly appears to be a quadratic function. This example, by the way, is meant to be you throwing a ball up into the air. So we've got time measured across the horizontal axis in seconds and the height of the ball above ground on the vertical axis. If the initial height is 10, that's an indication that you're not standing on the ground. 10 meters up is pretty high up. You must be on top of a building or on the top of a hill when you throw the ball. So we will right-click on one of the data points and click Add Trend Line. There's many options in Excel. We're going to choose Polynomial, Order 2 for a quadratic function, and we'll display the equation and the r-squared value on the chart. You can make the fonts bigger so you can read it more clearly. So we've ended up getting an r-squared value that is almost perfectly 1, and that we can see visually because the curve almost hits the data points. It's very, very close. It appears to pretty much hit this one here. It almost hits this one here, and it almost hits this one at the very end over here. 0.9947 or 99.47% is very high. So it's a very, very good fit. The equation of the curve is shown here, and it's not a surprise that the value of A, the vertical stretch factor, is about -5. And it's not surprising at all that the value of C is close to 10, because we threw the ball from a height of 10, and we've got 9.3333 as our value of C.